footage showcases the failure of a switch on a transmission line observed from a safe distance. The energy released in the arc is substantial. Being in close proximity during such an event would be dangerous. The cause of the switch failure is not explicitly stated. It could be due to several factors. Firstly, insulation breakdown. Over time, the insulating materials within the switch, such as porcelain or polymers, can degrade due to environmental factors like temperature variations, ultraviolet radiation, pollution, and moisture. This degradation reduces the insulation's ability to withstand high voltage, leading to a breakdown and subsequent arc. Secondly, overvoltage events. Transient overvoltages caused by lightning strikes or switching surges can exceed the switch's voltage rating. These overvoltages stress the insulation and can initiate an arc. Surge arresters are typically installed to protect equipment from overvoltages, but their failure or inadequate rating can leave the switch vulnerable. Thirdly, contamination. Accumulation of dirt, dust, salt, or other contaminants on the switch's surface can create conductive paths, reducing the effective insulation resistance. This contamination, especially when combined with moisture, can lead to surface cracking and flashover, initiating an arc. Regular cleaning and maintenance are crucial to prevent contamination-related failures. Fourthly, mechanical stress. Mechanical stresses on the switch components, caused by vibration, thermal expansion and contraction, or improper insulation, can weaken the structure and lead to cracks or fractures in the insulating materials. These defects can compromise the insulation and initiate an arc. Fifthly, corrosion. Corrosion of metallic components within the switch, such as contacts or conductors, can increase resistance and generate heat. This heat can further degrade the insulation and lead to arcing. Regular inspection and corrosion protection measures are necessary to prevent corrosion-related failures. Sixthly, aging. Like all electrical equipment, switches have a limited lifespan. Over time, the materials degrade, and the probability of failure increases. Regular inspection, testing, and replacement of aging switches are essential to maintain system reliability. Seventhly, improper maintenance. Lack of proper maintenance, such as lubrication, tightening of connections, and inspection for signs of wear or damage, can accelerate the degradation of the switch and increase the risk of failure. A well-defined maintenance schedule is crucial for ensuring the reliable operation of switches. Eighthly, manufacturing defects. Manufacturing defects in the switch components, such as voids in the insulation or imperfections in the metal castings, can weaken the structure and lead to premature failure. Quality control measures during manufacturing are essential to minimize the risk of defects. Ninthly, environmental conditions. Extreme environmental conditions, such as high humidity, temperature, or altitude, can stress the switch components and accelerate degradation. Selecting switches that are suitable for the specific environmental conditions is crucial. Tenthly, improper operation. Operating the switch beyond its rated capacity, such as exceeding the current or voltage limits, can overload the components and lead to failure. Proper training and adherence to operating procedures are essential to prevent improper operation. In summary, the failure of a transmission line switch can be attributed to a combination of factors, including insulation breakdown, overvoltage events, contamination, mechanical stress, corrosion, aging, improper maintenance, manufacturing defects, environmental conditions, and improper operation. Regular inspection, testing, maintenance, and replacement of aging switches are crucial to ensure the reliable operation of transmission lines and prevent costly outages. The exact cause in the video is impossible to determine without detailed inspection and analysis of the failed equipment. However, understanding potential failure mechanisms helps to prevent similar incidents. High voltage equipment requires careful design, installation, and maintenance to ensure safety and reliability. The video is a reminder of the potential dangers involved and the importance of safety protocols.